Okay, so we started discussing calculus, and the idea is that in the beginning I'm not going to write any formulae, rather I would be developing intuition. Okay, those intuitions we are going to make mathematically concrete later. Is that okay? So that's what we have been doing, that's why we didn't write any equations. So let's imagine the following. Imagine you guys, okay, all you friends, you all are going for an expedition. Okay, you are going to go for a mountain climbing. So you have some mountains where you want to go. It could be like, so imagine this to be like one mountain range rather than two peaks. So it's go here, there, something like this. Okay. Now you are sitting at the base camp and someone provides you with the map of the mountain which you are going to trek. Now it turns out the person who provided you the map did not give you the map of the mountain, meaning he didn't give you the height of mountain at different locations, right? So you imagine here is the camp is somewhere here, you start climbing, okay, and you go like this. So that's not what he has given. He has not given you the height as a function of distance from the boot camp, but he has given you the slope at each point. So he has given you what the slope is at this point, okay, corresponding slope of the mountain, what's the slope at that point, what's the slope at all these points. That kind of map has been given to you. Okay. Now you want to figure out from that information where are you going to set up, where you are going to set up your camp when you're climbing up. Okay, you want a place where it will be flat so that you can put your tents and take rest. You want to figure that out from this map, which does not have this picture but only a graph or a curve which gives you slope at each point. Question is, can you figure that out? Okay, this is what our question would be, and by the end of this lecture you will see that you can figure that out easily. Okay, and we will not write still any equation in this lecture, and from the next one we will start putting everything that we have developed in this first two lectures concretely in mathematical terms. Okay, good. So that's why we have these two mountains. So let's develop some ideas. So I want to introduce some terminology. Okay, so suppose you are given a mountain. Where was it? Here. Okay, that's not what I like. Okay, so suppose you are given a mountain of this kind. Okay, this is not a good software. So what should I do? I don't want that anymore. Okay, that's a mountain. Very roundish, old mountain, right? New mountains are very sharp. There is another mountain which is new one. Maybe I'll put it here itself. So okay, that's okay, not so nice. It's okay. You can imagine that it's touching nicely there. These are two mountains. Okay. Now when you look at these two, you already have some feel for the difference in the curves, difference in the shapes. This guy is very smooth. This guy is not smooth. It has a kink. Okay, a kink at this location. Where is the kink? Okay, it doesn't do anything. Why? This location, it has a kink. It does not have a kink here. It's smooth here. It's smooth everywhere here. Here, only at this point, there is a kink. Okay? But you look here, everywhere it's smooth. Whatever you understand by smooth is enough for now. We'll make all this precise much later, but that's what we see. Okay? So we say this has a kink at x equal to a. Okay? So at x equal to a, this mountain has a kink. Okay, kink means a sudden jump or a sudden turn in the shape of the curve. Okay, so it's a very sharp turn. This guy is smooth everywhere, that guy is smooth everywhere except for that point, and it has a kink. Okay, now let's make this a little precise, what we mean by a kink. So let's take any point on this. So here is the height. I'm not very emotionally attached to mountains and heights. It's just a little easier to start with, and eventually we will get rid of mountains and we will talk in more general. Okay? Take any point here, because all points are, at all the points this appears to be smooth. So let's take any point. Let's say this one. Let's call it A prime. Okay? Remember, this is called A prime. It's not called A dash. Dash is this. This is prime. So don't say this is dash. Okay, that's a dash. That's a prime. If you want to write A dash, that's A dash. If you want to write A prime, that's A prime. Okay, so we'll call A prime, not A dash. Now let's look at this point. Corresponding to x equal to A prime, let's figure out what the height is. The height is here. Okay, this is the height. Now let's look at the neighboring points. Points close to A prime, and make some statements about the hill, about the mountain. Okay, so I want to take points close to, oh my goodness, close to A prime. Okay, I am looking at what is happening in the neighborhood of A prime. What is happening here is not going to be influenced by what is happening here. This mountain could have been like this. That doesn't bother what happens here. So I am looking at the mountain locally. Local is the word, okay? So I am going to look at things locally. If you are a Hindi speaking person, locally means sthaniya. Us sthan ka. Okay? So we are going to look at things locally. So let's go back here. Let's see. Let's take this point. Okay? Corresponding to this point, you are here. I don't know why it keeps. Corresponding to this point, okay, maybe let's clean it up a bit. Okay. So let's take this point. Corresponding to this x, you have a point here. Okay. At this point, you draw that line, the tangent line, okay? The line tangent to the curve. That slope of that line is the slope of your mountain there. So it has some slope. Now you go to this point a little closer to A prime. So you are coming to A prime from the left. Okay? When you are here, at this point, the slope, as you can see, is still positive as it was here, but the slope is little lesser now. Earlier it was going like this, now it's turning like this. Now you go here. Now you're somewhere here. The slope is still positive, but the value has reduced. As you keep going closer and closer to A prime, you can see the slope remains positive, but keeps becoming smaller and smaller in magnitude. Is that okay? Are you following?
Yes.
Okay. So you see, slope is large, positive, still positive but less, but of a smaller magnitude, still positive but of a smaller magnitude, still positive of a smaller magnitude, and you reach here. Okay. Now let's do another thing. Let's start coming from this side. I take this point. I look at the slope, whatever that is, at this point. Okay. You see it's negative. The slope is negative. It's this line. If you draw a tangent to the curve, the straight line that you get will have a negative slope. And that is the slope you assign to the curve at that point. So that's negative. As you keep going this way, it keeps changing smoothly, it keeps changing continuously, becomes lesser and lesser negative, and eventually it reaches the same value here. Which means, if you look at point A and you want to know what the slope here is of the mountain, as you approach from the left, whatever slope you get as you approach from the left is the same you get as you approach from the right. You get the same answer for the slope, and I'm not trying to tell you the slope at that point. Okay, I'm not saying slope at A prime, I'm saying slope at any point which is as close as you want to A prime. Okay? These numbers are very close. Whether you reach from the left, you reach from the right, the limiting slopes that you get are almost are the same. Okay? Now look here. It's very different. What's this? Let's say this is 45 degrees. Okay, and that's also 45 degrees with respect to this. So that's will have a slope will be
1.
And slope here of this is minus 1, okay? Assuming that these are 45 degrees. What's the slope at that point?
1.
What's the slope at this point? This point?
1.
Slope at this point, I'm coming close to A, okay? What's the slope at this point? 1. So 1, 1, 1, 1, 1. When you are very close to this point, any point close to the left of A, your slope is 1. Now you come from that side. Slope is minus 1. Slope at this point is minus 1. Slope at this point is minus 1. Minus 1, minus 1, minus 1, minus 1. As close as you come to A, it still remains minus 1. You see, you're coming very close to A. From this side it is 1. From another side it is minus 1. It means the slope at that point is not defined. Right? And that is what you are seeing as a kink here. It's smooth here. So you see the slope that you get from that side in the limiting process, from that side from the limiting process, they are same. Here they are different. Okay, this mountain could have been a little different. Can't I erase that?
No, you have to select from the bottom.
What should I select?
4th item.
Which one?
4th one.
This is
No, 4th.
1, 2, 3, 4. Okay. Like this. And then delete. Nice. So let's look at another one.
You have to go back to pen.
Okay. Good. Let's say you have that kind of mountain. Okay. It is smooth everywhere here. The slope is also changing. You see? You keep coming here, the slope is different. The slope starts, whatever value it takes close to this point. Luckily, I have that point again at A. It's coincidence. But as you come from that side, the slope is very different. You see, there is a kink. So the slope from that side and that side will not match. Okay, that's what we mean by a kink. So this curve is, this is not smooth, that mountain is smooth, that's not smooth. Okay, good. So this will be useful for us later. So I'll give you some examples of mountains that are smooth and some mountains that are not smooth. Okay, how about this? My goodness. How about this? This is smooth everywhere. How about this mountain? That's smooth everywhere. How about this mountain? That's of course has a kink. Okay. Now let's go to this situation. This. Yeah, this. Okay. That kind of thing I want to consider now. So let's go to 3. Let us, okay, it's, I think it is straight. Let's take a curve like this. Okay, it's not very convenient. Okay, let's take this curve. Let's take this kind of a portion of this mountain, a portion of a mountain which looks like this. Okay, let's see, let's look at the region between these 2 points A and B. Okay, where does the height take its maximum value? Okay, at what value of x does the height become maximum? Clearly, it's maximum at B. Okay, so height is maximum at B. Now this maximum is maximum in the entire region between A and B where you are interested. Okay, it is a global maximum. Globe, you understand, when you say globe, the entire earth. Okay, so in its entirety it takes its maximum value here. So that's a global maximum. Okay, so this point at B we have a global maximum. Okay, it takes the largest value. And where does it have its minimum? Minimum value, minimum height is attained at point A. Okay, so at point A we have global minimum. Okay, but that's not very useful for the problem we had in mind. You remember, you are all sitting in the room, you are going for expedition and you have been given these charts and you want to figure out where to put your camp in the night or in the evening. Okay, you want to reach that place and all you have been given is the slope at each point. Okay, so this is fine. Now I'll give you another one. We'll see how those things are connected to this. So let's go to another one. Now 1, 2, 3, 4. Why doesn't it come? Sorry, here. Okay, let's take another mountain, and this time again I am interested in this region A and B. Okay, so that's A. Okay, it cannot go. That's point A here, that's point B here. Okay, and let's take a mountain of this kind. Okay, let's turn it into this, or So this is our region of interest from A to B. Where does the mountain attain its maximum height in this region A and B? It is at B. Where does it attain its minimum value? It's at A. Okay. But then there are two other points which are very interesting. It is this point M and N. Okay. Now what's special about M? What's special about M? What do you think what's special about M? Any ideas? No? You see, if you are at M, at this point, okay, meaning you're sitting here, and if you look in the vicinity of M, in the neighborhood of, vicinity, close, every point other than the point M, every other point, at every other point, the height of the hill or the mountain is lower than the height that you have at M. Let's say the height here is 1 kilometer, or let's say half a kilometer. Okay. The height clearly here is less than half kilometer. That's also less than half kilometer, right? At every point here is less than half a kilometer. Similarly, this point, okay, it's, I think it should be this one. That's N, not this one. Let's leave that out. Here, every point has a height more than the height at point N. Okay? So if you're just looking there, it's like, oh, every other point, as you move to the left or to the right, the height is going to increase. So locally, when you're seeing locally, this is a point of maximum. Height is maximum at that point in the neighborhood of that point. It's a local maximum. Similarly here, every other point has a larger height compared to this one, N. So at point N, you have a local minimum. So these are the names. So here, and local is extremely important. Remember, this is locally a maximum, but globally, this is the maximum. Here it is locally a minimum, but globally, this is the minimum. But also see, the behavior of the hill, the nature of the hill or mountain at local maximum and local minimum is appearing to be very different from global maximum and global minimum. You don't have that kind of a shape here. You don't have that thing. You don't have that kind of a shape here. Right? You may have, but it's not necessary. Things, it will fall down. Careful. Okay? So we say local maximum. And this is local minimum. So as I said, it is possible to have, so you imagine a curve like this. So it comes like this and then it goes like this. Right? Then you have that kind of thing. So not only that it is a global minimum at that point, it's also a local minimum at that point. Okay? Okay, so we'll not worry about these things. Let's proceed. So two important concepts: local maximum, local minimum. Okay, we are learning a lot about mountains and hills. Now we can go on expeditions. Okay, excellent. This is 11. And 13. Okay, nice. Now we are going to make some extremely important observation, very important observation. So I'll just tell you, the things which I am telling are usually towards the very end of your calculus, differential calculus. And I am telling you at the very beginning, okay, because it's easier to understand when you are already not struggling with equations and abstractions. We all know hills, mountains. Is there any difficulty so far? Okay. Good. So let's go to next page. What do I want to do? Remember, we were going on expedition and we have a map which does not give you the shape of the mountain but the slope of the mountain, shape of the slope. Okay. Okay, so let's continue. That's our goal. My goodness. Why? What happened? Okay, sorry, I understood. Just a second. So 1, 2, 3, 4. No, straight line. It's already selected. Okay. Okay, fine. I think this is fine. Is that straight? Yes. Now, what kind of shape I want to take? Yes. So let's take a mountain. So I have to keep touching this, right? That's a nice mountain. So you can climb up, then you can go down the valley, okay, and climb up here. So you climb up, and you go down. That's x. And the vertical axis is the height. Fine? Remember, you might not understand everything now. But if you sleep well in the night, or maybe for 2 nights, things will settle down in your brain. Okay? So there is no point in just sitting for long and long hours hoping that it will come settle in your brain. No. Study, think, and then sleep. The more you sleep, the better it is. Okay? So anyway, let's go to this. Another observation. Is this point, okay, let me ask a question. Is this anything special about this point? Anything special about this point?
Local maximum.
This is a local maximum. Okay, that's where we are. I'm sorry, this is not straight. This is local minimum. Okay, so point A, point B. A is local maximum. I'll just write it down here. Local maximum. And B is local. Local is important. Minimum. Local doesn't mean cheap quality thing. Local means something manufactured locally. Okay, in the neighborhood. Now let's see here. Now I'll plot this one. What color will be good? Do you think this will get recorded? Will it be visible? Let's take yellow. Is it visible in the camera?
Yes.
Okay. I hope it's straight. Okay. Is it straight? It's straight.
Yes.
Almost, huh? Okay, I don't want this anymore. X. Okay. Tell me about the sign of the slope at points to the left of A, in the neighborhood of A. Is it positive or negative?
Positive.
And it is becoming smaller and smaller and becomes 0 here. Okay. So let's take 0. And what I am plotting on this is not the height. I am plotting the slope of the mountain. Slope of mountain. Okay? And here slope is negative, right? So let's work in this region, in the neighborhood of this. So these are, so this is the point A here, and this is the region in which I am working. Okay? So slope has some positive value. It doesn't matter to me how much. Some value, let's say 1, 2, whatever it is. It's actually more than 1. You can see it's not 45 degrees but more. So let's say 2. So let's say 2. Okay, and at some point it becomes minus 2. Don't take all the numbers seriously. I'm just giving you a rough picture. So at this point, the slope is not 2. This is 2. Slope is, let's say, half or something like that. Okay, it might be even. So slope is this much. Okay, let's say this is 1, this is half. So slope at this point is somewhere here. As you come closer, let's say this point, that is this point here, it's the same x-axis, okay? At this point, the slope is lower. This is the slope. At this point, you have still lower slope. At this point, what's the slope? At point A, the slope is? 0. Okay? As you go further, slope is becoming negative and increasing in magnitude. Right? You agree? So I'm going below the 0 now, below this horizontal line, so it's becoming negative and negative. So it's roughly like this. Agreed? Something of that sort. Let's look at point B. Here the slope is negative. Okay? Negative, but its value keeps decreasing and becomes 0. So its slope is 0 here, and if you are to the left, its slope is negative. Okay? See, magnitude keeps decreasing as you come closer to B, that's what I'm showing. Then it starts becoming positive, so it's 0, a little bit more, more, and becomes larger. So it starts becoming positive and its magnitude starts increasing. So that's the behavior, sorry, too many lines. That is what it looks like in the neighborhood of B. And that is what it looks like in the neighborhood of A. Right? Now, no matter what it looks like, whether it is this or whether it is this or whether it is this, as long as it's a maximum, that's the behavior you expect. Whether it is more shallow or whether it is very steep shallow, this behavior is going to be the same. You should be able to argue for yourself. Okay? Now, see, whether it is this or little this or little that, that's different. That will depend on the shape of that. Similarly here. But the general feature that you will have a line going like this and a line going like that for the slope is going to remain the same. That you should be able to argue for yourself. Okay. Good. Now forget the mountain. Let's look only at this part. At A, you have a small piece of line which is telling you about how the mountain looks at A. This line, if you just look at this line, forget everything, this line, is the slope of this line positive or negative?
Negative.
The slope of this line is negative. Slope. What is this? What is plotted here? What is plotted here is slope. Slope is plotted here. Okay? What's the sign of the slope of slope? Negative. That's a line, right? That's a straight line. I can ask, what's the slope of this line? Is it positive or negative? It's negative. So slope of mountain is negative. Where you have a local maximum. Agreed? Look at this point. at point B, the slope of the mountain has this, is this. Okay? What is the slope of the slope? This curve, this thing is giving you the slope. So what's the slope of the slope? Is it negative or positive?
Positive.
Positive. The place where you have a local minimum in the mountain, its slope will be
Positive.
0. Its slope is 0. The slope is 0. Slope is 0. But the slope of the slope will have a positive sign. This is a line of positive slope. Agreed? So here, slope, if you look at the slope of this, which is slope of the slope of mountain, then it is positive. Agreed? Very good. If you really understand this, and then now let's go to our camp. Here is the map, which is very unfortunate map because you have not been given the shape of the mountain. Someone has given this thing to you, right? And this thing will, if you start finding out, it will be something, I'm just vaguely, something of this sort. Okay? But I don't care about those things. Let's look here. Now, we are sitting in our room, wondering about, okay, this guy seems to be winking, but it's that's unintentional. We want to go to the mountain, okay, and we want to decide where to set up our camp, but we don't have that information. We have only the slope of the mountain. So so this is given to us. This is the base camp. Half kilometer, 1 kilometer, 1.5, 2 kilometers. Okay, this is all in kilometers. And then a slope is given to you. You want to know where is the peak or the local maximum, where it's going to be like this or where it's going to be like this. You can set up a camp there or set up a camp there. You don't want to set up a camp on the slope. So what are those points? What's special about those places?
The local maxima.
Yes. But what's special about that?
Slope.
Slope is 0. So what you do is that slope function that has been given to you, you find out where it takes 0 value. So suppose it's given like this. So I think we had something of that sort, right? So what you are going to do is you are going to identify these points. These are the candidate points where either you have a local maximum where you can put your camp or a local minimum. These two. No other point. Right? Here the slope is 0. But that's the slope of slope that is 0. That's not what we are looking at. We are looking at slope to be 0. Now, we also want to know, so where do you want to put up the camp? Okay, you guys decide. You want to put up your camp here or you want to put up the camp in the valley? Valley? Okay. Valley means local minimum. At local minimum, the sign of the slope is, the sign of the slope of slope is positive. Sign of the slope of slope. Okay? That's the slope. Let's look at the slope of this. At this point, the slope is negative. You see? If I draw a tangent to this is the line I get, right? And this has a negative slope. If I am getting a negative slope, then it will be a maximum. We saw on the previous slide. Let me show you. Slope is negative, you had a maximum. Okay. Here, so that's not the place where you want to put the camp, right? You want it to be in this value. Here, the slope is positive. Sorry, slope is positive. So slope of this curve, because this is just the slope, this is slope function. I'm looking at the slope, so it's positive. And as you saw here, if the slope of the slope is positive, then mountain is like that, local minimum. So you can happily put your camp here. That's where you want to do. So let's say 2 kilometers, 3, 4, 5, 6, half, 1, 1.5, 2, 2.53, 3.54, 4.5, 5. At 5 kilometers you want, from the base, you want to set up your camp, you can happily win there. Is that okay? Now last observation. No, I have more. Tired already? Hardly said a thing. Okay, so if you are tired, we'll stop here. But just see another thing. It's curious. Let me draw some local maxima. Okay, don't worry, I'm not going to teach you anything else. Okay, maximum here, maximum there, maximum there, maximum there. If you look close to the point at which you have maximum, this point, right? Look at this. Look here. Look here. Don't they all look like a parabola? Just in that window. If you are just looking at this, you might imagine that this is part of a parabola. Right? You might imagine that that's part of a parabola. That's part of a parabola. That's part of a parabola. Does it look like that? Minimum. Steep minimum. Shallow minimum. If you just look in the vicinity of that point, you can imagine, you can easily fit a parabola there. Does it look like that? Parabolas. We'll stop here with the observation that looks like there are parabolas in the game somehow. We'll worry about that later, but that's something you should notice. Good? So, we'll stop here, and you have now learned about local maximum, local minimum, and what are the conditions that need to be satisfied for a point to be a local maximum or a local minimum. Okay? Okay, we'll stop here. You can stop.